Welcome to day 2 of section 3.2, where we are solving systems of linear equations. So what do you do if nothing cancels? So we looked at one example where we had to work for it. We had to change the signs on the equations so that one of the variables would disappear. But if nothing will cancel, you can use multiplication to make equivalent equations. So in other words, I'm going to multiply both of the equations by something so that they have a common, well, almost common, the opposites of each other. So for example, if I'm looking at this system right here, if I were to just add these together, nothing would happen. What we want is to eliminate either an x or a y. And if I just add these up right now, obviously that's not going to happen. Even if I change the signs on them, I won't be able to eliminate a variable. But if I just look at the x's, or I could look at the y's, but just looking at these x's here, if I take the 2x and the 3x, I can say, what could I multiply so that they would both be the same thing with an opposite sign? Well, I could take the first equation and I could multiply it by 3, and I could take the second equation and multiply it by 2, and that would make them both 6's. Then the only thing I'd have to do is change the signs on one of them. So that's what we're going to do. We're going to go back up here and erase. I'm going to erase my little lines here. And I'm going to say, I'm going to take this first equation, and I'm going to multiply it by 3. And I'm going to take the second equation, I'm going to multiply it by 2, and then I'm going to pick one of them to be negative. So I'll take the top one to be negative. So if I do that, I'm going to get 2x times negative 3, and I'm going to rewrite it over here as negative 6x. And then negative 3 times the 7y becomes negative 21y. And then the negative 3 times the 4 equals negative 12. Then I do the same thing on the bottom, but this time I'm multiplying by just 2. So if the 3x times 2 is 6x, the 5y times 2 is plus 10y, and finally the negative 5 times 2 is negative 10. So now that I do have opposites, my x's will disappear. My y's become negative 11y, and this is equal to negative 22. All right, so it's only a step or two more than what we did before. Finally, divide by negative 11, and that will give me my y value. So y is equal to 2. All right, so I have half my answer. Now again, I have many examples of where I could plug this in. I can put it into anything with an x and a y. I probably don't want to use the larger numbers that I just created, so I'm going to go back to my original one. So I'm going to pick the 2x plus 7y. Since we just found y, I'm going to say it's 2x plus 7 times what we just found y to be, 2, is equal to 4. So I don't have to use my new equations again. I can use what I had before. So I get 2x plus 14 is equal to 4. Subtract 14, subtract 14. So 2x is equal to negative 10. Divide by 2, divide by 2. And x is equal to negative 5. So I now have my x and my y. I just have to put them as an ordered pair. So my answer is negative 5 and 2. And if you plug those into your original equations, you should get 2 true statements. All right, let's look at another example. What is the solution for this system? We're going to eliminate this part B question, so you don't have to do that part. All right, so if I'm looking at this, obviously no x's or y's will disappear if I just add them together. So I could really pick this time whether I wanted to eliminate the x's or the y's. Usually it doesn't matter. So I'm going to pick the x's. So I'm going to multiply this equation by something and this equation by something. And remember, the x's have to be opposites of each other, and they have to be something that 3 and 5 both go into. I hope you're thinking 15, because that would be a good one. So that would make the top being multiplied by 5 and the bottom by 3. You can always get there by just multiplying by the other number, but sometimes you'll be multiplying it by really big numbers. So always look for what their least common multiple is. All right, so again, one of these has to be negative. This time I'm going to make the bottom one negative. All right, so the top is going to become 15x plus 35y is equal to 5 times 15 is 75. On the bottom, I have the 5x times the negative 3, negative 15x. And then the negative 3 times the 2y is minus 6y is equal to, and then negative 4 times negative 3 is positive 12. So let's see what I have left over. As I worked out, the x's are gone. My y's become 35y minus 6y becomes 29y. And 75 plus 12 makes 87. Ooh, these don't look like very nice numbers. But if I divide by 29 and divide by 29, well, look what happens. I get y is equal to 3. Right, so it still worked out well in the end. Sometimes these don't work out. All of our answers aren't all whole numbers. So if I have y is 3, again, I don't know that I want to use one of these two equations at this point because I have really big numbers. So I'm going to pick the one that makes the most sense. So for me, I'm looking at the 5x plus 2y equals negative 4. So I'm going to say 5x plus 2 times my new y value of 3 is equal to negative 4. In other words, 5x plus 6 equals negative 4. Subtract 6 from both sides. So 5x is equal to negative 10. Divide by 5, divide by 5, and you will find that x is equal to negative 2. So your final answer for this is negative 2 and 3. Once again, how can you check to make sure you did it right? Well, let's see if you remember. All right, the last problems we have interesting things that happen. So all of our answers so far have been 1 point, but that's not the only thing that can happen. Okay, when we look at this next one, if I were just to add these together, I don't need to multiply them both by anything. If I add the x's together, the x's are gone. But so are the y's. So the x's cross out, the y's cross out, leaving me with that whole side is just 0. On the other side, I add those and I also get 0. If everything crosses out, what that means is I have a whole lot of solutions. In fact, there are an infinite number of solutions. That's the infinity sign, by the way. An infinite number of solutions. There are all kinds of things I could put in for x and y to make this true. Not just one thing like has been so far. Now you might be asking, how is that possible? Well, with all the other problems we did, they crossed at 1 point. That 1 point that we're looking at is our solution. For these ones, if there's an infinite number of solutions, everything on this line and everything on this line would be the same thing. So they are, in fact, exactly the same line. So that's what happens if this situation happens. Now, it doesn't have to be just 0 equals 0. It makes any true statement. So if it says 8 equals 8 or 12 equals 12 or negative 3 equals negative 3, it's still an infinite number of solutions. For the next example, again, I'm going to look at it and I'm going to say, no, again, I don't have to change anything. I just try putting them together and sure enough, the x's are gone and the y's. But this time, not the constants. If I add those together, I get 16. Now, when does 0 equal 16? Again, hopefully you said never. 0 will never equal 16. If that's the case, there are no solutions. If I get my variables to disappear, then nothing can work in that one. That would be an example of lines that look like this. They never will cross. And you may have guessed they have to be parallel for that to work. All right, if there are no solutions, we have this symbol that can represent it. So no solutions. All right, so let's look at the last example we have here. what is the solution for the following system? So if I'm looking at this one, I have to do something. So what am I going to do? I'm going to multiply the top by 2. All right, so if I times this by 2, I'm going to rewrite it as negative 2x plus 2y is equal to negative 4. I got to make sure I multiply every part by the 2. The bottom part, I don't have to multiply by anything because now I will have exactly the opposites for the x's. But not just for the x's. The x's are gone, but so are the y's, leaving me with 0 equals negative 4. Does 0 equal negative 4? No. And so that means the answer is no solutions. For the next example, if I'm looking at this, again, I have to make a variable disappear. So if I wanted my y's this time to disappear, so I have a y and a 3y, I could multiply just the top equation by negative 3. So if I multiply that across, I'm going to get negative 12x. And then y times negative 3 is minus 3y is equal to, and then 6 times negative 3 is negative 18. The bottom equation, I'm just going to rewrite 12x plus 3y is equal to 18. And again, if I add those together, just like I expected, my y's are gone, but again, so are my x's. So I get 0 is equal to 0. So again, if that's the situation, then there are an infinite number of solutions. All right. So again, your homework is listed down here. And for this one, we are going to cross off this last part and just make it 53 and 55. All right, so 31 through 43 odd, 44 through 50 even, and then 53 and 55. All right, have a good weekend. We'll see you on Monday.